to Gnana Deeksha concept-based digital learning. Today, I am here with an interesting and important concept. Here is beautiful stories awaiting you. Without any delay, let's get started. Hope you know Yama Dharmaraj and Chitragupta. Well, for the past 3 months, there were unusual increase in the number of persons to hell. Lord Emma decided to visit Earth along with his assistant Chitragupta. They observed the pandemic situation on the Earth due to widespread of coronavirus. Also heard police were trying to create awareness about COVID-19 by taking his name. Yama is looking at you. If you don't follow lockdown rules and come out on the roads, surely he takes you away. A boy named Tom, who is suffering from diabetes, did not care police words. Unnecessarily came out all the time. Soon he affected with COVID-19 and died. We believe sinners are seen in hell. Who is sinner? The person who breaks law. The moment Chitragupta saw him, started reading his record. Tom begged Yama not to punish him. Tom left with 2 options. Either he has to lie on bed of nails or to stand on it. Tom decided to stand on bed of nails. Yama laughed at him and said, "Foolish boy, you don't know the concept behind it. If you stand on it, you hurt more, feel more pain rather than lying on it." Children, do you know the reason why he hurts more when he stands on it? Think it. Let's observe other scenarios. If you were asked to cut an apple, what do you choose? Either a sharp knife or blunt knife. Without any thought, you say sharp knife. Why do you choose sharp knife? What do you see in second picture? Yes, it is military tank. Carefully, if you observe its wheels, those are not similar to normal wheels. You can see here a chain. These chains are called caterpillar tracks. Tell me why we need to put a chain? Think it. Let's move to third picture. I enjoy camel ride. Won't you? Mostly we see camels in desert. Why camel moves faster than horse in desert? Let's explore the answer with an activity. If you have pencil, pick it immediately. Make sure it should be sharpened. Place a pencil between your index fingers and press from both sides. What do you observe? Pencil leaves a mark on finger pressing the sharpened end. We applied equal amount of force on both the fingers, but the effect of force is different. Area of the sharpened end is smaller than the area of head of the pencil. We observed that effect of force depends on area of contact. When there is decrease in area of contact, the effect of force increases. When there is increase in area of contact, the effect of force decreases. Let's perform other activity. Take 2 trays filled with sand and take 2 rectangular bricks of equal mass and shape. Place one brick vertically in first tray and other brick horizontally in second tray. Remove them after a while. What do you observe? Yes, brick which is placed vertically sinks deeper in sand than the brick standing horizontally. From these activities, we finally conclude that if area of contact is less, effect of force is more. If area of contact is more, effect of force is less. Yes, on larger area, force is getting divided. Effect of force does not depend only on force. It also depends on area. So, we need a special quantity in physics to explain this. That is pressure. Learning objectives of this class. You are going to define today pressure and applications of pressure. How fluids exert pressure. Defining the atmospheric pressure and factors affecting the atmospheric pressure. What happens if pressure difference exists and some of its practical examples? So, topic of today's class is pressure and its applications. Pressure. Pressure is equal to thrust by area. Children, tell me, what is thrust? It's a kind of force. When I ask you to fix a nail, how do you fix it? You apply force on it perpendicularly. So, force acting on an object perpendicular to the surface is called thrust. Let's have a look on unit of thrust. Just now I told you thrust is a kind of force. The unit of force is Newton. So, the unit of thrust is also Newton. Thrust is a vector quantity. Vector quantity means the quantity which has both magnitude and direction. Let's come back to the pressure. The thrust acting on unit area of the surface is called as pressure. Pressure is equal to thrust by area. The unit of thrust is Newton. Unit of area is meter square. So, Newton by meter square is the unit of pressure in SI system. Then in CGS system, yes, dyne by centimeter square is the unit of pressure in CGS system. Let's come back. Newton by meter square, which can also be called as Pascal. When thrust of 1 Newton acts on area of 1 meter square, then we say pressure is 1 Pascal. You just take your 50 rupee note and place it on your palm. Pressure that you feel is 1 Pascal. Since it is very small, we generally use in physics kilopascal. 1 kilopascal is equal to 10 power 3 Pascal. To honor the achievements of Blaise Pascal, unit is named after his name. Children, you must relate science with your daily life and then you enjoy it. Start making connections. Let's have a look on the applications of pressure in daily life. Shall we go back to our questions? Ready? Yes. Our first question is, why a person hurt more when he stands on bed of nails? Here is the answer for you. People lying on bed of nails, so surprising. They lie comfortably on nails and nothing happens to them. If one nail can cause lot of bleeding and pain, how can they lie on bed of nails? On bed of nails, all the nails are of exactly same height. Overall, it makes a bigger surface. Just now we learned that when area is more, pressure is less. When pressure decreases, its impact also decreases. Let's go back to camel's feet sink much less in the sand. Now tell me how pressure and area are related. When area increases, pressure decreases. When area decreases, pressure increases. Let's take other scenario. It is easy to cut vegetables with short knife because it has sharp edge. So area of contact on the object is less. It exerts more pressure. Small amount of force is enough to cut. Have a look on your school bag. If you have it, just have a look on it. Why your bag has white straps? School bag is quite heavy. School bag is quite heavy. You keep everything in it, including your biscuits, chocolates and everything. So the weight is going to carry by your shoulders. If the strap is broader, its area is more. Then its pressure going to be very less. You can carry it without any pain. Let us switch to other example. This is a military tanker which is heavier than normal vehicles. Imagine when there is no chain, wheels would be directly touching the ground. Complete weight of the tank will be concentrated on these tiny areas just like a needle. As a result, there is high pressure on the ground. Tank may sink into the ground. It is pretty hard to move. If you put a chain, weight of the tank will be same. But look at the contact area. Now, force gets divided. As a result, pressure gets reduced. So, by observing all these examples, in some situations, the effect of force is increased in tools like knives, axes. But in some situations, the effect of force is reduced. like laying the foundations of dams and buildings. So these are the few examples of pressure in our daily life. You may find many. Till now, you have seen pressure exerted by solids on other solids. Solids exert pressure in the direction of its weight, which is downward. So, solids exert pressure in downward direction. Do fluids exert pressure? What are fluids? A substance which can flow from one point to another point is called fluid. Since liquids and gases can flow, so they are known as fluids. Does fluid pressure depend on size, shape and area? You might be surprised to know that fluid pressure does not depend on size, shape and area. You have learned just now that pressure depends on area. This is true only in the case of solids. But when it comes to fluids, that is liquids and gases, the pressure exerted is independent of area. Liquids exert pressure at all points in all directions. Liquids don't have any specific shape. Molecules in liquid move randomly. Let us perform an activity. Take a glass tube which has open ends on both sides. Tie a rubber balloon to its lower end. Pour water into the tube. You notice balloon bulges downwards. This shows that liquids exert pressure on the base of the container. Let's switch to other activity. Take a vessel with tap on its side. Tie a balloon to the opening and fill the vessel with water. What we observe? That balloon bulges outwards. This shows that liquids exert pressure not only on the base of the container but also sideways, that is on the walls of the container. Let's have one more activity. Take a football, immerse it in bucket which contains water. Let's see what happens. Immediately, ball comes up with a force and floats on water. This shows that water exerts pressure in the upward direction. So by this, we can say fluids exert downward, upward and lateral pressure. Children, tell me how this liquid pressure is measured. This is measured by an instrument called manometer. You can easily make your own manometer. The difference in the liquid levels in the U-shaped tube is a measure of the pressure applied by the water. Let us check how pressure varies with depth. We understand this concept with an activity. Take a bottle, you can add some color into it and fill it with water. Make 4 holes at different heights. You see, water comes out of the holes. What we observe, that water from the bottom hole comes out with higher speed and falls farther. This shows that the pressure in a liquid increases with increasing depth. At same depth, pressure is same in all directions. This is the reason when submarine divers go deep into the ocean crushed by the water. Let's know the types of pressure. They are absolute pressure, gauge pressure, atmospheric pressure. In this session, we are going to discuss about atmospheric pressure. Shall we observe few scenarios on this? Are you ready? Here, you see an astronaut who wears a special suit. Why do astronauts wear special suit when they leave spacecraft? What happens if they don't? Have a look here. You want to drink your favorite juice? When you order for juice, they serve you with a straw. Why we need to suck with straw? Why juices don't directly enter into the straw? Have you ever seen a fountain pen? Have you ever wondered if a fountain pen is taken to higher altitude, it gets leaked? Why? Why? Let's explore the answer for these questions. Tell me, what is atmosphere? Atmosphere is a layer of gases around the earth. Earth is surrounded by air, which extends to kilometers. We have different layers like troposphere, stratosphere, mesosphere, thermosphere and exosphere. We live on troposphere. Atmosphere is made up of millions of molecules. We know every molecule possesses weight. All these molecules are attracted by the Earth's gravity. Molecules exert their weight on the surface of the Earth. So, atmosphere exerts pressure on the Earth. Pressure exerted by the air is called atmospheric pressure. So, let us define atmospheric pressure. The thrust exerted on unit area of Earth's surface due to column of air is called the atmospheric pressure on Earth's surface. You might wonder how big this atmospheric pressure is. One atmospheric pressure is equal to 1,01,325 Pascal. 1,01,325 Pascal is roughly equals to 100 kg of mass is acting on our head. How come it's not affecting us? Actually, we should feel heaviness. The atmospheric pressure is compensated or cancelled or counterbalanced by the pressure exerted by gases which are present in our body. Let us have a look what are the factors that affect the atmospheric pressure. It is affected by altitude, temperature, humidity. Let's see first how atmospheric pressure changes with altitude. Let's see first how atmospheric pressure changes with altitude. As we go to higher altitude, air becomes thinner and atmospheric pressure decreases. On the surface of the earth, density of molecules present in air is more. As we go up, density of molecules present in air decreases. Gradually, atmospheric pressure decreases. Let's see the first relation between temperature and atmospheric pressure. Air expands on heating, we know it. When it expands, it becomes less dense. So, atmospheric pressure decreases with increase in temperature. The relation between humidity and atmospheric pressure. Water vapor is lighter than air. Hence, air pressure decreases as humidity increases. Here are few interesting questions. Please have a look on it. Why do astronauts wear special suit when they leave a spacecraft? Yes, in space there are no molecules, so there is no question of atmosphere. Pressure outside of astronaut body is equal to 0, but there is pressure inside his body due to gases. We know that pressure travels from high pressure region to low pressure region, there is a chance of bleeding of nose. At a point comes, he may die. That is the reason why astronauts wear a special suit. Here is other question for you. Why we need to suck with straw? Why juices don't directly enter into the straw? Yes. While drinking with straw, first we have to suck air in the straw, which will reduce the pressure inside the straw. There is presence of atmospheric pressure on the surface of the drink, which forces the drink of the straw to your mouth. Next question. If a fountain pen is taken to higher altitude, it gets leaked. Why? When you take your pen to hill station, it starts leaking. As we go higher, density of air decreases. Number of molecules decreases. So atmospheric pressure increases. Pressure inside the pen is greater than the atmospheric pressure. So that is the reason fountain pen leaks. Atmospheric pressure is measured by an instrument called barometer, which is invented by Evangelista Torricelli, which is called mercury barometer. Measurement of atmospheric pressure using barometer. Atmospheric pressure can be obtained by a barometer using the formula P equals to HdG, whereas H equals to height of the liquid column, D equals to the density of the barometric liquid, whereas G is the acceleration due to gravity. If H is expressed in meters, D is expressed in kg by meter cube, whereas G in terms of meter by second square. For a given barometer, D, that is density and acceleration due to gravity, are constant, and atmospheric pressure is proportional to the height of the mercury column. 1 atmosphere is equal to 1.013 into 10 power 5 Pascal. So let us summarize our class, what we have learned today. Pressure. Pressure is the force acting perpendicularly on a unit area of the object. Pressure is equal to thrust by area, Newton by meter square, or dyne by centimeter square in CGS system. When a force acts over a large area of an object, it produces a small pressure. If the same force acts over a small area of the object, it produces a large pressure. Fluids exert pressure. Liquid pressure is measured by an instrument called manometer. The thrust exerted on unit area of Earth's surface due to column of air is called the atmospheric pressure on Earth's surface. Factors affecting atmospheric pressure are altitude, temperature, humidity. Atmospheric pressure measured by an instrument called barometer, invented by Torricelli. Let us end our session with top 2 questions. Explain why buildings and dams have wide foundations. Second question, a force of 100 Newton is applied to an object of area 2 meters square. Calculate the pressure. So these are the questions for you. I hope concepts are very clear for you. I am looking forward for your answers. Thank you.